Hi grade 8. Today we're going through a tutorial on how to draw a observation deck or game viewing tower. So the scenario that we have is that you are an architect who has been commissioned to design a game viewing tower for a wealthy game lodge owner. And he has given you some specific specifications of what he wants in his tower. So let's have a look at some of those. He specifically wants it to be 5 meters high so that you can see far and you can see his rhinoceroses and all of that sort of thing. And it needs to be 5 meters wide because he's got lots of people. It's 5 by 5, so 5 meters high, 5 meters wide, and 5 meters deep. So it's going to be a pretty big platform that you've got, and he can have big parties and large groups of people because he doesn't have to worry about COVID. Right, so because it's so big, we have to have very sturdy foundations. It needs to have a safety rail because you can't have your clients falling off your tower and plummeting to the lions below. And it has to have stair access because sometimes, you know, if it was a ladder, the old ladies wouldn't be able to get up or something. And it needs to have a roof in case he wants to view his game in the rain. So as a very quick overview, this was one of my test drawings that I put together to say, okay, but this term we've been focusing on structures or load-bearing structures. So we spent a lot of time looking at bridges, thought that we would change things up a little bit and have a look at a tower. Now, you might be wondering what this jester dude is for. It's not just for keeping us company. We are using him more or less as scale. Okay, so this drawing here is when I was just figuring out all of the tests and the sizes and everything to determine, it worked out more or less to a 1 in 50 scale. So every 2 centimeters on this page, it represents 1 meter in real life. So this guy is about, let's see, 4 centimeters high. So in reality, if he was to scale the scale of this drawing, he'd be a giant of 2 meters tall. But, you know, it's not impossible for people to be 2 meters tall. So if you have a look here, to get an understanding of the proportions for our Lego dude to climb up the stairs, get into the deck, he's a big guy. He's very, very tall, but he would fit proportionally quite nicely. But it did also show me that, in fact, the rail and the roof are probably out of proportion. They're too high. So I used that to just get an idea of how big we were going to need to make this, and just looking at the very generic kind of design that we would use. So what I've done over here in this page is I've started with the layout information. So if you were given a task like this to draw, which you're going to be doing in this activity or this tutorial, is you're going to draw your own tower as well. I'm going to get you started. I'll show you some of my ideas and we can chat through them and just take some of those considerations. But if you get given a task like this, so you've got the specifications and you need somewhere to start, the best place to start is to start with the center line. We know that, you know, for majority of things like this, the majority of it is symmetrical. We've got the stairs coming down the side, but everything else, this is the center line. So that's a good place to start. Drop a center line down with your page. All you need for this activity or this tutorial is a ruler and a pen, preferably a ballpoint pen. Avoid using pencils because if you use a pencil, it means you can rub out lines. And if you can rub out lines, then it just, you spend more time rubbing things out than actually drawing. And this is something you need to learn as in drawing, is that you shouldn't be scared of your lines. So if you put down a line and it's squiff, you know, like if I put down a line, boop, it's light enough that it's not a problem. So, you know, sometimes if you feel like you just can't, you don't know what to do, you don't know how to start, just like drop a very light line somewhere on the page. Be like, this page doesn't matter that much that I can put a line like this through my page. There's a line. Who cares, right? Draw with a pen. It'll boost your confidence as you go. It's very important to learn how to get those different page or those line weights. And we've spoken a little bit about that earlier in the term. If you are drawing very light lines, sometimes it gets like a residue on the tip of your pen. And if you just grab a piece of toilet paper or whatever and wipe that off every now and then you avoid things like this happening. Okay, I draw left-handed as well. So what happens is my hand is always moving over what I draw. And so if you're left-handed, you understand, you just get like these ink marks on your hands all the time. But yeah, if you're aware of that, you can just wipe it off before it becomes a problem. Cool, so drawing. What we've done is we've dropped the center line. You can see the other lines, it doesn't matter, it's not an issue. We know that our game viewing tower needs to be 5 meters high, and the scale is 1 in 50, which means that for every 2 centimeters, that's 1 meter. So if we want to get it 5 meters high, it needs to be 10 centimeters from our page. But that means that we need to have a reference line to start with, a ground plane. So what I did is I've measured 3 centimeters from the edge of the page, because we've got foundations. Our foundations are below the ground, because remember, one of our criteria is that we have to have foundations. So I'm going to specify that the foundations need to be, I spoke to my engineer, and he said that they need to be 2 centimeters, which is 1 meter wide and 1 meter deep, to support a structure of this size. So what you can see is I've got my center line, I've drawn my ground plane, and I've done it so that it's 3 centimeters above the edge of the page, so that the bottom of my foundation doesn't go off the edge of the page. And I've done that at 15 centimeters out, which if we sort of just look at the proportion of the tower, we want our tower to be nice and stable. So I've made the base wider than the deck, and it just, you know, hopefully makes it nice and sturdy. So you can draw 2 centimeters by 2 centimeter block, and that represents our concrete foundations. And you can see that I've just drawn a little note. Okay, originally my plan was to just have a solid block, and I realized that it doesn't actually need that. It can just have a block on each post. So the concrete foundation is now over there. And that's how we just quickly annotate what's going on in our design. We can see where I've put a thing to say, that's the support beam, that's the deck, that's the corrugated roof, there's the safety rail, there's the stair safety rail, and you know, the stairs, that's pretty obvious. So we've drawn our ground plane, our foundations go below it, and that's 2 centimeters by 2 centimeters deep, and in the scale of things that would then equate to 1 meter deep, 1 meter wide. It's quite a hefty foundation point for our tower to be based on. Then what we can do is we can take your ruler, you can measure 10 centimeters up. Remember, 10 centimeters would be 5 meters in real life. And because it's also 5 meters wide, we can just take it from the center, that's 5. So we'll put a point there, put a point there, and now we know that this is how big our deck needs to be. So we already know from the ground how high our deck needs to be in proportion, how wide our deck needs to be. And then because it's quite a high tower, I'm going to go with a meter high rail, so that it's kind of sitting, if you have a look at your Lego man, if he was an average height, it would kind of be like just above his belly button level or so. Let's say he was actually not 2 meters tall, he was only, we could take his hat off as well, then he'd be shorter, and that's going to be sort of just above his center line, which means that if he leans over, he's unlikely to fall off the edge of the rail. So 1 meter high is good. A kitchen counter is generally about 900 millimeters or 90 centimeters, so just less than 1 meter. So then I said, we don't want our roof to be super high. It's not like a normal ceiling, which is about 2.2 meters high or 2.1-ish, round about there. But it can be 2 meters high to keep it reasonably low, so the game doesn't see you when you're on your deck and you are checking them out, seeing what they do when they drink at the water hole or whatever. So there I've just 1 meter, which is 2 centimeters, another 2 centimeters. I've just made little marks so that we can start to see, right, the deck height needs to be, let's keep it from the top so that we can keep that parallel. The deck height needs to be more or less there. And again, it doesn't matter how far you extend that, you can decide how big you want to make it at a later stage. And then we'll put another line across the top for the roof line. So this is the bottom of the roof. We can go up above that because there's generally a pitch to the roof. If we have a look at my early sketch, So this space is much higher than what we're going to draw in this tutorial one, and we'll need to decide the pitch of the roof. Now, a corrugated iron roof doesn't need to have a very high pitch, so it could be flatter than that, and but I think it looks balanced and proportionate if it's got a little bit more of a pitch. And maybe you could say that, you know, as the architect, you wanted to have a higher ceiling so that the people who are standing inside here, if it's hot, are not going to get so much heat coming off the corrugated iron and burning their scalp or something like that. Right, so we've started to construct more or less the size of our tower, and this is going to be important for you to just make a note of for your exams. When we come to, we'll give you a set of specifications like this, and you're going to need to follow those carefully and then come up with a design of your own for something. That's why we're doing this drawing tutorial. We've done a couple of different drawing projects throughout the term or throughout the year so far, but we just thought that we'd give you a bit of a boost in that. Give his hat back on again. Right, so let's see. We also need to have our stairs, and we'll look at sort of having a reasonably gentle pitch for that. One of the challenges is that we've only got so much paper. So I don't know, maybe let's say if it comes out 2 meters, the center of our foundation is about there and there. So if we go 2 meters from the base of our, and let's go 2.5 meters, that'll be nice and sort of reasonably gentle, because you don't want them to feel like they're climbing a ladder, because remember the little old ladies who need to, you know, go and watch the elephants drink water and frolic in the mud. So there we've got more or less our stairway area. We've got our deck area, and I think that's the next thing that we're going to do. So we know that our deck needs to be at 5 meters high. So if we want to build the deck up, we can draw below that line. Now, it's not super important for us to get the proportions perfectly. We don't know what size sort of boards they're going to use for the deck there, but we do know that it needs to be more or less in proportion. So I'm going to draw it out there, and that gives us a nice sort of middle starting point so that we can work out on our design. But really the core focus of this exercise is to sort of look at how we construct this, so that we're not just designing by drawing random lines and seeing, oh well, that works, that looks nice. You know, generally a drawing is constructed, so you start with the center line, you start with all the important dimensions, and then you work out. Wherever we don't specify a dimension or like a measurement, then it's up to you. So you can see what makes sense, what is reasonable. Like obviously you're not going to make the deck 3 meters thick, because then it's going to be down here or whatever. It's like not appropriate, guys. So we've got our deck. I can draw the deck in a little bit, the construction line that I did initially, can draw it a little bit darker so we can see that that is quite clearly our deck. And as you draw, initially, when you start drawing, you're putting your construction lines in, draw as lightly as you can, and as you go, you're going to get sort of closer and closer to your final design. Then you can start making the drawings a lot darker. One of the other things you'll notice is that a lot of this I did draw with a ruler, but sorry, the noisy traffic next door. If something's drawn with a ruler, it looks very cold and precise. And it often lacks that sort of hand-drawn aesthetic, which makes a drawing actually look a lot better generally. So if you have a look here, now once I've drawn the overall form and I've used rulers to construct it, I actually go over by hand and just draw that line in. And if you go a little bit squiff, whatever, it actually adds to the drawing a lot of the time. So don't be scared of using a natural hand-drawn line, because a lot of the time, especially as a professional product designer, this is something that I studied, and using a hand-drawn drawing, if you take a drawing like this to somebody who's paying you money to design something, or if you take something that looks clinical and constructed, clients and people generally prefer to see something that looks more hand-drawn. So that's something to keep in mind. Obviously, we want to keep it neat and accurate and clear, but the whole purpose of drawing is to communicate, and hand-drawn lines are generally much more expressive. So yeah, keep that in mind. You can see that I haven't actually drawn the solid lines over there. It's still sitting on construction lines, so I can put that in and draw a nice thickish line, go over it even. not technically best practice to go over a line once you've drawn a solid line, but it doesn't look bad from that perspective. Okay, so let's go back to this. I am drawing on 2 pages so that you can get your line weight more easily. If you're drawing on a hard surface on a single piece of paper, often the lines are very, very thin and sharp because the ball of the pen can't actually go into the page nicely. So if you have another page behind it, it gives it a little bit of a cushioning and allows you to get more expressive lines that you can control the depth by pressing harder or softer to get your lines. But just remember that when you press very lightly, there's more likely to be excess ink, and you'll get the ugly smudge things that I'm showing you over there. Right, so yeah, that's how we sort of start to construct the base of our tower. Let's see what else we can do very quickly. I don't want this video to take forever, but you're going to build an observation or design an observation deck. Remember, it's got to have a roof, it's got to have safety stairs access. So we started the base of the stairs, it needs to have safety rails. And so what I'm going to do here is I'm going to say, if we measure outwards, the safety rail for the stairs needs to be also around about, if we made it 2 centimeters, that would be a full meter. That's quite a lot. So I'll probably make it at 15 millimeters, which is 750 mils, which is quite a high rail, but it's still sort of at a reasonable hand length. So I'm going to put a mark over there, just very lightly construct that in so that we can see the height of our rail versus the height of the stairwell section over there. It's probably not going to start at that angle going all the way down into the corner, so I can put a post over there. And we also need to have some sort of foundation for our stairs to be grounded in. Obviously it doesn't have to be as big as that, so we can just indicate that there is some sort of foundation here. And if you want to be sort of correct, you can indicate that it's below the ground by doing a cross-sectional hatch lines, and then you can see that this has kind of been cut away, and you can see what's happening in there. Right, so we'll have a post going in over there to hold up our rail. It'll stick out a little bit above the hand, and now we can start taking it up like that. We want our foundations to start at this point over there and over there, at least our main beams. So I'm going to keep with that cross sort of angling in design, and we'll sort of take it maybe 1 centimeter in from the edge. That's about 0.5 meter from the edge of the deck, so I'll just put a mark over there again to try and keep the construction and the design accurate. We use the ruler, take it down. So there's the one sort of the center line of the main beam that's supporting everything. Let's line it up over there like that and do the other one. So now you can see the base of our tower coming together at angled in like that. And then we'll also say we're going to have our triangulation sitting more or less from there to there, and it's going to go, and we can just do the dot to dot thing and extend it. We've got a nice triangulated part, and you can be creative. Obviously it's a worrying thing when engineers or architects get too creative around structural designs. We know that triangulation is strong and that makes for rigid structures, but your triangles have to be in a place that actually do increase the rigidity of the structure. So they'd be bolted together over there, but these beams have thickness, and so we can bring that out so that try and keep it more or less in proportion. Bring it up like that, so you can see we've got a beam there, a beam there. You can figure out how to draw the beam, which one sits in front and which one sits behind. We can take that one down, the main supporting beam going into our concrete foundation. And there you can see very quickly, and again, I'm not drawing with the ruler now because we're running out of time. I don't want this video to be much longer than 20 minutes. Then we can start to say, right, we want our deck to, our safety rail to go up a little bit. as an outwards way, so you can sort of walk up right to the edge of the deck and look over. Maybe there's a lion down there. And then you can start to bring in some more detail. We can have our main roof support beams going straight up. It can be triangulated on the inside or something like that. Maybe we'll have some triangulation parts going up and connecting to the roof beam. And the roof we're going to extend out a bit like that. And then, as you said, there's a center point for our roof, the pitch of our roof, and we can bring it up like that and like that. So you can see, right, we've got the roof, we've got the rail height. We can start to give the rail some thickness, the safety rail, top deck. And now we can go back and we can say, let's stick our giant Lego man in, take his hat off so he's slightly more average size. You can see that there, the rail sitting slightly above his waistline, so that's good. If it's below his waistline, he could maybe sort of walk and accidentally trip and then fall over the edge and land in the lions. But he's also not likely to bump his head badly on the top there. And there we can start to see the form coming together. Obviously you want to then start to add detail around your railings, and we can slowly bring it in. And you can construct that. You can draw it painstakingly with your ruler, or you can do the quick thing like I've just done here. I did spend a little bit more time on this because I wanted to get it right before we went into the tutorial part. And so you can add detail as you go. So you can see what I've done on the roof here is I've given a little bit of an idea that is made out of corrugated iron. So you could start by just drawing, and this doesn't have to be exact. It's more to just communicate the idea. Because remember that a lot of the time as a designer, you're going to take this and show it to your client, and he's going to say, oh, well, I don't really like that, or I don't like this. Can you change that? And if you spend ages and ages just working on one design, it's like, but you're killing my baby. And so it's an iterative process. So you're going to start off and you're going to draw it sort of more or less loosely, and you're going to add, and as you do different revisions, you're going to get it more and more refined. And the last sort of final one, you're going to spend hours just making it really, really beautiful. But remember that we don't have time for that right now. So that's as good as it gets, and you're going to try and use your different line weights to bring out more clarity. You can see here, still very lightly constructed. Nothing is made very dark yet. You can see that once you're done, you can add those darker shadow lines to make sure that like the lines that you want people to see stand out. So you can see immediately the difference between something like that and something like that. The main difference is that the lines are darker. Right, and then you're going to include things like the safety rail, maybe some triangulation coming through on the rail like that, and you can start to bring in detail. Remember, the important part is to keep the proportions right, to make sure you're following the brief, keeping the setup dimensions correct. So remember that this base section over here was supposed to be 5 meters high, which would be 10 centimeters in the drawing. That's going to be another 2 centimeters, which is 1 meter in real life. So that's the rail height, another 2 centimeters for the roof height, if you can read that. And then when you do note or annotations for a drawing like this, it generally looks better if you keep the notes in caps. So my handwriting is just terrible in general. I blame it on the fact that I'm ambidextrous and dyslexic, but that's just an excuse. In general, if you keep it all caps, it makes it look a little bit more professional. When you do arrows, don't do like an arrow like this, please, because then it just like takes a cool drawing and makes it look awful. Just have less is more. If you really want to put it, you don't even need to put a little pointy bit on the end. I've always been bad at drawing arrows, but keep it quick, keep it light. As I said, less is more. There's some very sort of quick drawn arrows to point at different things, and generally looks better than if you construct your arrow and have this massive thick thing that takes up more space and attention than the drawing itself. So that's some ideas and guidelines on drawing what did I call it? a game viewing observation deck or game viewing tower. Now it's your turn. So remember, it needs to be 5 meters high, which is going to be 10 centimeters in the scale we're working here. The scale we're using is 2 centimeters equal 1 meter. Remember, don't ignore that. That was just me thinking on paper. So 2 centimeters equals 1 meter. And if we get it to the same units, 2 centimeters equals 100 centimeters, because 1 meter is 100 centimeters, but we want the scale to be 1 to something. So we divide it by 2, we get 1 to 50, and that is our scale for the drawing. I hope that was helpful. I hope that you have fun doing this project or this tutorial. Spend some time doing this. I think that it's really a worthwhile thing to be doing. It's a really, really important skill, and I think it's a lot of fun. I enjoy sketching a lot, and I hope that going through something like this can help you to enjoy it too. Go well, and good luck with the rest of the term and going into your exams. Catch you next term.